All right, your focus question for today. How can I identify the perpendicular? Use that symbol for perpendicular so you don't have to write it out. How can I identify the perpendicular bisectors of a triangle? How can I identify the perpendicular bisectors of a triangle? Let's start off with a regular perpendicular bisector. Draw a segment on your paper and label it AB. And then draw a vertical segment and try to intersect the two at 90 degrees and in the middle of AB. And you can label that one CD. We're going to say that CD is a perpendicular bisector of AB. So since it's a perpendicular bisector, that angle is 90 degrees. And the distance from A to the point of intersection is going to be congruent to the point of intersection to B. So if we call this point E in here, then you can say that AE is congruent to EB. Now there's a rule about perpendicular bisectors. Theorem 5.1 on page 324 says that if a point is on the perpendicular bisector of a segment, then it is equal distance from the end points of a segment. So if CD is the perpendicular bisector, C is on that perpendicular bisector. Well, that theorem says that point C is equal distance to A as it is to B. So those two segments are congruent as well. They're not going to be the same measure, but they're congruent. And since point D is on the perpendicular bisector, what do you know about DB and DA? They're congruent as well. Very good. And that gets 3 hash marks. Any point on CD will be the same distance to A as it is to B. Okay? So write that down, please. If a point is on the perpendicular bisector, if a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segment. Questions? All right, the converse of that statement, Think about this. This says that if a point is on the perpendicular bisector, then it's the same distance from the endpoints. All right? What if you're told that a point is the same distance from the two endpoints of the segment? Could you say that it's on the perpendicular bisector? All right? And that's exactly what this picture could represent. Draw another segment. Or you don't have, just watch. Just watch right here. Now you got a segment and another that intersects it. Okay? And if you're told that this point, point A, is the same distance from B as it is from C. Okay? So say you get this picture here. And you're told that AC is congruent to AB. Well, then what do you know about this angle?
It's a right angle.
It's a right angle. Okay? Because the vertical line's a perpendicular bisector. And if we call this D, what do you know about BD? Very good. It's congruent to DC. Okay? So that's the converse of the theorem. And that would say that if a point is equal distance from the endpoints of a segment, then it is on the perpendicular bisector. Any questions there? Look in your book, please. Drawing three lines that intersect at the same point. Label the lines L, M, and N. The point where they all intersect, we'll call it C. That point is called point of concurrency. Point of concurrency. That's where three or more lines intersect. Point of concurrency. That's where three or more lines intersect. How many perpendicular bisectors do you think a triangle has?
None. No.
Perpendicular bisector splits a segment in half, right? At 90 degrees. So how many do you think a triangle has? 3, right? Triangle's got 3 sides, so a triangle has 3 perpendicular bisectors. 1 for each side. Does that make sense? Draw an acute triangle. And label it ABC. Take side AB and perpendicular bisector it. Construct or draw a perpendicular bisector. It's got to intersect it at 90, right? And it's got to hit it in the middle. So that looks about right. You agreed? What's this angle going to be? It's going to be a right angle, and this piece is going to be congruent to this piece. If you do the same thing for side BC, find the middle of BC. You can eyeball it. Draw a segment at 90 degrees. Yep, it's going to be a right angle. The two pieces are going to be congruent to each other because bisect means to split in half, right? You see what's going to happen next? Yeah, it's going to go right down the middle. When you bisect this third side, it's going to go right through the other two. That's why it's 3. There's your 3 perpendicular bisectors. They all hit inside this triangle. That's called a point of concurrency, isn't it? In this case, where the 3 perpendicular bisectors meet, that's called the circumcenter. The circumcenter, that's equal distance from all vertices. The circumcenter, it's equal distance from all vertices. And I'm going to share this with you because I think it's cool. Can you picture or imagine a circle that goes around this triangle, that goes through each vertex?
Yeah.
Can you picture that circle? Kind of looks something like, let's see. I missed. What do you think the middle of that circle is?
The circumcenter.
Yep. The middle of that circle, there's a circle that goes around every triangle. It goes through the 3 vertices of every triangle there is. All right? The middle of that circle is called the circumcenter. What would this represent right here? From the middle of the circle, or from the circumcenter to vertex A?
The radius.
Very good, the radius of that circle. All right, and if you drew another line from the circumcenter to point B, it's the radius as well, isn't it? And the radius is going to be the same all the way around the circle. So the distance from the circumcenter to each vertex is the same. All right? So this is an acute triangle, isn't it? In an acute triangle, the circumcenter is in the middle, or it's inside the triangle. Okay? If you were to picture or draw an obtuse triangle, where do you think that circumcenter is going to be? Can you picture a circle going around this triangle? It's only going to catch a little portion right here, right? Way down there. It's going to be huge way out here. It's going to be a circle. See it? I mean, if I had a tool that I could draw a good circle and hit those vertices exactly, it would look about like that, wouldn't it? Where would the circumcenter be?
Right there.
Inside or outside the circle?
Outside.
Okay. So for an obtuse triangle, the circumcenter is outside the circle. For an acute triangle, the circumcenter is inside the circle. All right? And then you got one more triangle here. If you could picture a right triangle. If it's inside of an acute triangle, do you think it's inside of a right triangle?
Yep.
Vertex? All right, so if you were to draw this is a big one. think about what you just said. If the circumcenter is inside of an acute triangle and it's outside of an obtuse triangle,
It's on the line.
a right triangle is right here. It's right on the hypotenuse. Yeah, I know it's on the top of page 326, but I'm recording the notes and you guys don't have books outside of class, so I just wanted to show it. So in a right triangle, the circumcenter is on the hypotenuse of the triangle. Okay? Just bad circle. Bad circle. Good teaching, but bad circle. Oof, that's bad circle. That's getting better. Oh, it's getting much better. That's, oh.
Just gotta keep making it bigger until it's
Oh, okay.
I want to edit this out.
Nah, I don't care. You get the point?
No.
You get the point. Circumcenter. In a right triangle, it's going to be on the hypotenuse. So,
So we're going to be determining if an angle is.
the last thing, yeah, well, no, what you're going to get asked some questions about how far. Here's the last thing you got to know. Write down this theorem that the perpendicular bisectors of a triangle are concurrent at the circumcenter. Which is equal distance from the vertices. Perpendicular bisectors of a triangle are concurrent at the circumcenter, which is equal distance from the vertices. That's what you need to get out of it. Any questions? We're going to talk about angle bisectors tomorrow.